Thanks everybody for coming today. Today we have Drew presenting, as you see on your screen, about Git Patch Stack. I hope you enjoy. Take it away.
Cool. All right. I guess for those of you that are not developers here, Git Patch Stack is a tool that a lot of us use here to manage how we make changes to our software locally on our machines. And it's an open source project that I started a long time ago, years and years and years ago, been maintaining for years. But we just released version 7.0, like, I don't know, 20, 30 minutes ago. And so I figured we would do a presentation on 7.0 because it's a pretty significant release in the scale of releases that we've done historically. So let's get into it. And don't hesitate to ask questions if you have questions along the way. I don't care. You could interrupt me a bunch of times. If we don't finish the presentation, that's fine. I don't really care. As long as you get what you want out of it. All right. So, as I mentioned, this is a different release than we've done historically. Historically, we've kind of released continuously. So as soon as like we find a bug and fix that bug, I'd cut a new release and people would get the fix for that bug right away, for example, right? Or we add a new feature, we'd cut a release and people would get that build that includes that new feature right away. This worked and worked fine for a bunch of people. But there was also other people that didn't seem to pay attention to those updates or didn't care because they're happy enough with the way the tool was, or they just didn't want to be bothered by paying attention to Slack notifications about small changes that sometimes might be interesting, other times might not be interesting. So with this release, I decided let's try to go old school and like do a large major release that bundles up a bunch of changes all together. And then instead of just doing a Slack notice about it to everybody, we can actually do a presentation on all of it. And so that's what this is about. So this marks the beginning of a few major mental and strategic shifts that we've made in Git Patch Stack as a whole. This isn't just here's some new features. This is like we've consciously decided to strategically handle and do things in different ways. So the first shift that we had along those is what I'll call state. And historically, we tracked state. So this meant like as the program would do different activities, we would record information about what happened in terms of patches. And a patch is just a change to code, right? So we'd record that locally in a file. And we'd record things like, you know, that a patch had a branch created and associated to it, or that a patch was pushed up to a remote Git repository. And we would record what the remote was, what the branch was, some information about the diff, which is the change itself, etc. We'd also track whether it was requested review or whether it was integrated or not. And this is all fine and dandy. And we stored this information in a local file inside of your Git repositories. You can go poke around and look in your local Git repos if you want, people, and you can check out the state and see the state there. And you can see if you blew it away, all of a sudden GPS would no longer know anything about your patches. And it would have to rebuild all of that state. So this was simple. It was straightforward. It was a good way to start. But over time, we discovered it has lots of flaws, right? The first flaw is that we would get numerous reports of state tracking becoming out of alignment with Git. So what would happen is that people would use Patch Stack, and then they would go do some normal Git operations related to the patches that were in their stack or that were in branches related to their stack. And then they'd come back and Patch Stack would be in a different state than their Git is. And they'd be like, what the hell? This seems broken. And it's like, yes, that's because you went out of bounds of Patch Stack and didn't use the Patch Stack workflow, and you used like part of the Patch Stack workflow and then decided to go do some Git stuff outside of it. So that's one. So we have another one, which is that the state that we tracked, a large percentage of it was what we call fabricated state. So it's like state that we made up, state that's impossible to get or represent from Get. And this was largely because we were also caching state from remote systems. So like, for example, GitHub would know about the fact that a pull request was created, but Git itself has no knowledge of the fact that a pull request was created, right? And we would cache locally and get Patch Stack state that a pull request was created. So we're effectively caching that state, and that just creates more opportunity for state to be out of sync because we're not getting it from the source of truth. So then we have yet another flaw, which is there are people trying to use Patch Stack across multiple remotes. For example, where you are on one machine working on a Git repository, and then later in the day or a different day, you're trying to work on another machine, and you no longer have that knowledge and state of all of your patches in your Patch Stack. So there's people trying to do this and failing and struggling to do that because the state was stored locally in a file in their .git folder. Like, there's nothing we could do about that. And there was hacky approaches people were taking to try to solve this problem, but none of them were great. So we decided with 7.0, because it's this big major release, we might as well introduce some breaking changes and just change how everything works. Let's not track state anymore. Let's instead compute state. So the idea is that instead of tracking state when people take and manipulate things by running commands, we instead look at sources of truth for state and run computation on them in real time and aggregate them into a state data structure that the application cares about to represent its world. So this has some benefits. Like, one big one is it's impossible for Git state to be out of sync with Git Patch Stack state because Git Patch Stack state's computed from Git state now. So you can't, go out of bounds and cause any problems because the state is what the state is in Git. This also gives us the benefit of sharing state across repositories because since the state is Git state's already shared across repositories as part of Git. That's what happens when we do a push or a pull, and all of those processes, right? We're sharing state back and forth across these repositories. So if we do this and we compute state from the Git state, then magically we get that for free. We also, can have people use only a piece of Git Patch Stack, only the pieces that they want, that they value, and they don't have to worry about the other pieces because they won't break state by doing that. People were already doing that, but dealing with this broken state issue. And so that could theoretically go away. It also enables composition with other extensions and tools, which is another thing that we saw people wanting to do, is figuring out different ways of utilizing Patch Stack with other tools to have whatever their personalized custom workflow is. In addition to that, there's this side effect that fell out of this, which is that we have this better alignment with Git modeling in general, right? And this enabled us to implement a long requested feature that probably the majority of the user base has been asking for since day one. I think Claude was probably the first person to ask for this feature. And that is patch series support. So it is now an official first-class citizen. It's fundamentally baked into the core design of the application now, and it's not an afterthought or a hack in any way, shape, or form. What is a patch series? Well, it's a consecutive sequence of patches. That's it. Usually they're dependent on each other, but they don't have to be. You could just use it as an organizational structure to group related patches if you want, or you can use it to request review for a collection of patches together, even if they're not dependent on each other. But in the pure like patch stack workflow, historically, the point of it is of a patch series is to be like, hey, we have these patches that are dependent and cannot be separated from each other and have to happen in this particular order. And that's when you request review for a series of patches in the classic workflow. So this is what GPS LS looks like now in the New World Order. And you can see some things that are different here. We no longer have state representation on the left, right? The leftmost column is a patch index. And then the next column that we have is the SHA of the commit. And then we have the 50-character git commit summary. And then we have these weird parentheses things over on the right side in the last column. And that's the new layout. And there's a reason for it. We'll talk about it. But you can see here, we have an actual patch series inside of our stack. So if we look from the bottom up, we have this add mortgage calculator patch. We have an add loan calculator. Then we have this add REST client library. We have add login client, add login view to app. And then we have add savings calculator, right? Well, add REST client library all the way up to add login view to app are all dependent on each other. And they're a consecutive series of patches that need to go in together. And therefore, we've grouped them together into a patch series that we named login. That's why on the right side, we see the name of the patch series associated with those patches. And that says login. And then we see this L. And that L is an indicator telling us that that patch series, or that patch specifically, is inside of a local branch. And that's what the L means, is local. And then following that L will be state indicators, indicating the state between the patch in your patch stack and the patch that's in that patch series. Because a patch series behind the scenes is really just a branch, right? So there's a branch, if you were to look behind in the Git tree, that is called login, that has those patches in it also. And those patches also exist in your patch stack. And the state information is telling you state about whether or not those patches in that branch and locally in your patch stack are the same or not. If you had pushed that branch up to a remote, you would see an R there next to that L. And that R would indicate that there's a remote branch associated with that patch as well. And it gives you the same state information about that as well. So they're still part of the stack, right? They exist alongside other solo patches, which is what we saw in that screenshot before. And they can exist along other patch series. You can have as many patch series as you want in your stack. You can intermix patch series with solo patches or whatever, right? Do whatever to your heart's content. And the relationships are between patch series are the same kind of mechanism of control that we had for patches, which is simply order, right? So if something needs to depend on a patch series, well, that patch series needs to be lower than that thing in the patch stack. And so you can reorder a patch series. You can do all of the normal stuff like you normally would with Patch Stack, and it keeps track of all of that. So how do we go about defining or refining a patch series? Well, let's look at an example real quick. So this is a screenshot of the same patch stack before we defined it. And all we have to do is look and identify the patches that we want to be part of that series and identify their indexes inclusively. So we know add REST client library is the first one, so that's index 2. And we know that add login view to app is the last one in our series, and that's 5. And so all we do is we can do a git GPS branch -n login 2-5. And that creates our patch series for us. The branch command creates just a local branch. That's why we saw the L next to it in the previous example. And so it ends up resulting in this, right? No big deal, pretty simple. If we did a request review in the previous state instead of a branch, we would do the same thing. It would create the patch series, and then it would request review for it also. So you can bypass the defining of the series up front and do it all together as part of the request review if you want. It's up to you. So yeah, so how do we refine it? You just run the same command and you just either increase the patch index range or decrease it. And so if you want to include an additional patch, say patch 6, you would just go from 2-6 and it would update that patch series to include 2 through 6. If you want to shrink your patch series and get rid of a patch, you can just reduce the patch index range when you rerun the command. So yeah.
Hey Drew,
Yeah.
let's say I've got I did some commits and then I got sidetracked and did another commit. And so now there's a commit I don't want in my range. I got to reorder first before I run that, or is there a way to define like exclude 3 or whatever?
No, right now there's no way to exclude 3. You have to reorder in your stack, which is
Okay.
really what you want to do anyways, because you should be thinking about your patch series as like a logical entity in its own right. In terms of like relationships between it and other things that might depend on it. So yeah,
Fair.
so you reorder and then you adjust. Cool. And then so the core team, we implemented this, started using it, and ran into some difficulties visually tracking when we had a bunch of patches going on and trying to identify what the indexes were from this. And actually Harris kind of gave me the suggestion of, hey, well, what if we just like alternated colors between the different patch series? That might help. And so that's what we did. We needed a way to see this. So we implemented alternating patch series coloring. And that looks something like this. So now it actually makes it easier to visually see what's going on in terms of patch series. And GPS LS actually treats solo patches as if they are a patch series of 1, right? So that bottom patch, which is a solo patch to add mortgage calculator, that's a patch series of 1. That's why it's colored that way. And then patch index 1, add loan calculator, that's a different patch series of 1, conceptually in GPS LS's mind. And therefore, that is colored as the alternate color. And then we have login, and login is colored as the login patch series, and then 6 savings calculators alternate again. But you can see kind of the idea, and this makes it super easy now to see the boundaries where I can say, oh, cool, we have this login patch series here. But now I can easily see that 2 is the bottom and 5 is the top of that without much struggle. And so that's how we addressed it. If you hadn't defined a patch series, and you just do solo patches, which is what I try to do most of the time, you end up with a patch stack that looks like this. And this is just because GPSLS, again, sees each solo patch as a separate patch series of one patch, conceptually. Implementation-wise, it's not implemented that way behind the scenes, but that's how LS sees it and visualizes it. Cool. Colors. Colors are cool, but they have lots of problems. Okay? Lots of problems. You know, some people require different degrees of contrast to see colors. Some people's terminals are configured such that colors are different. For example, even if I said like, hey, let's use color red, which is formally defined in my terminal, and then you go to your terminal, that color red in your terminal is very much likely different than the color red in my terminal. Let alone your monitor configuration has massive impacts in how you perceive colors, but also people just interpret colors differently. You know, who knows? Maybe you're colorblind, right? And these are all problems that we have with colors. So to try to address these things a little bit, we shifted the app over to 24-bit color mode. So we're not using predefined terminal colors through the 16 color palette or through 16-bit color even. We're using 24-bit color mode. And also we set the default colors in 24-bit color mode. And those are all based off my personal color scheme that I use. But, you know, you may not like those, or maybe, you know, you need colors to be slightly different. That's fine. It's fully customizable. You can configure the colors however you want, change them to be whatever you want. It's all up to you. And that is patch series support. So let's talk about our next shift. Our next major shift is this concept of composition over opinion. So historically, we built Patch Stack based on a specific workflow. It was based on this idea of how we could do our work in a way that would make it so we are unblocked if we're having to wait for pull request peer review, but also in a way that it could hopefully facilitate pull requests being reviewed quicker and easier in a lot of cases by not having just massive pull requests. So we built it around that workflow, and that was kind of how we started thinking about it, and how we did it was with that state tracking. And so we had this issue where it was like, you had to really use the entire flow to stay within valid state. And so that led us to, we have to have a complete abstraction historically, right? Because if people left Patch Stack to go do something else in Git proper, they could get out of state. And this resulted in having these lots and lots of proxy commands, right? Because that meant that, like, hey, when we need to track state, that like you're doing something like just staging a change using git add, we don't want you to do that anymore. We want you to instead use GPS add. And GPS add's going to do the same thing that git add does, but we're going to do this slight little difference to it, and we're going to do some additional state tracking around it so we know what's going on, right? And so imagine that for like the bajillion of git commands that are out there, right? So we had this problem with trying to keep a complete abstraction in place. The other thing was, these are a massive maintenance problem, these proxy commands, because Git changes on a regular basis. There's constant releases that come out for Git, and the options that you can pass to each of these commands get changed on the regular from Git. And people constantly would create issues and bugs in Git Patch Stack where they're like, hey, I love that you have this GPS add command, but I really need this other option that you're not proxying through. Can you add support for that other option? And then you do that, and then you get 5 more requests like that. And so it's like this never-ending maintenance game. And then you're also trying to synchronize that with get proper all the time. So that was a massive flaw. And then we have this, there's a ton of different workflows that users have with Git. Like how I use Git is very different than how John uses Git or how Harris uses Git or how Hedges uses Git. There are things that are similar and that overlap, but then there's other things that each of us use that are different, right? It's very personalized how we actually do it. So we decided, well, we're not doing tracking of state anymore. We're now computing state. So we no longer have to be stuck in this mental mindset of having a complete abstraction. We don't have to conform to that anymore. So let's remove that and get rid of that completely and see what happens. Turns out that that enables us to have selective usage also, right? Where like, let's say John likes only this 3 or 4 features of GPS and doesn't care about the rest of them. He just wants those features. He values those, but he doesn't value the rest. And that's all he needs. He should be able to do that, right? I think so. So we've changed focus. We now have gone from an opinionated workflow to something that's like more of a general tool, allowing custom workflows. And to support this, we've removed a bunch of commands. We've removed all these proxy commands. Sync is gone, log is gone, create patch is gone, amend patch is gone, status is gone, unstage is gone, upstream patches is gone, add is gone. We just nuked them. And I can tell you it felt so damn good. So this has some benefits. I think removing all of these, for one, it massively simplifies the command surface area. When somebody is trying to figure out how to use this tool, they're looking at the help, they're not bombarded with like a bajillion commands that they have to worry about and think about. They're only confronted with the ones that are specific and provide significant value in the Git Patch Stack ecosystem. 2, I think it makes the intention of the command line tool more clear, right? Where instead of people being like, hey, it's great you have this add command, they are then like, cool, how do I add a thing? Oh, you just use git add. You don't have to use GPS add anymore. You just use git add, because now we compute the state from git proper, so you don't have to worry about it. So in addition to this whole like command surface area agenda, we also removed batch request review. And this is because we made batching a first-class citizen, and then we added that support to the request review command. We also added batching support in a generalized way, so we could trivially add it to other commands. We haven't added it to other commands yet, but it's like an easy, like 5-minute change to go add it to another command. And the reason we didn't add it to other commands was because we weren't sure that it made sense. We didn't have a use case for that yet, but we definitely had that use case for request review. And if you're not familiar with batch request review, it lets you request review for a whole series, or I don't want to use series, a number of independent patches all at the same time. So let's say you wanted to request review for patch 1 and 8 and 13, all as independent patches. You can do a batched request review of that now. You could do that before with the batch request review command, but now it's all integrated cleanly into the singular request review command. We had this branch command before, which was like our gateway to fake patch series historically. So it was like our scapegoat out of patch stack world into Git proper. And we've taken that and we no longer really need that because we have patch series support integrated natively. And so we basically merged that command and the request review branch together into a singular request or a singular branch command, which is like a fully supported first-class citizen command instead of kind of like, here's an escape, because there is no escape anymore because it's all just Git. So we did all of this. And some of like our fanatic users who like build off the source tree and use it from the source tree, they started making requests still for proxy commands. So even after all of this effort, they still wanted proxy commands and were requesting proxy commands. And I was like, there's no way in hell from a pure maintenance standpoint and the fact that this is a side project, I don't want to deal with all of that. There's no way that I'm adding a proxy command back into this thing. So then the question was, how do we deal with this? We need some way to support all these different custom workflows that all these people want. And that's where composition enters. So when we talk about composition, we're talking about composition of Git patch stack concepts with Git or any other command line tool for that matter, right? It doesn't matter. And to start this and kick this off as part of 7.0, we've introduced a new command. This is the GPS SHA command. And all it does is take in a patch index and dump out on standard out the SHA that's associated with that patch index. That's all this command does. Super simple. It's like a 5-line command in the code base. Super trivial, but it unlocks a huge amount of power in terms of composition. Because if we look at this little example, we can see maybe you're a person that loves the git commit -- fix up option, for example. If you're not familiar with this, it is a Git command to flag a particular commit to be fixed up into the commit above it when you do a rebase with the -- auto squash option, right? A lot of people love this process and this workflow. I particularly do not use it, but a lot of people do. So if they love this so much, this is how you would normally write this command if you wanted to do an amend. You would flag a commit for an amend. You would do git commit -- fix up equals amend : and then you'd give it the SHA of the commit. So it's like, okay, cool. Well, what if instead we want to elevate this to the conceptual level of patch stack? So instead of thinking about a SHA and thinking about a commit, we want to think in terms of patches. So we want to be able to do the same command, the git commit fix up, but we want to be able to do that relative to a patch index, not to a commit SHA. Well, with the GPS SHA command, we can do that on the shell trivially. We can just do git commit -- fix up equals amend : and then we do a subshell. And we use GPS SHA with whatever the index of the patch is that we want. And we've composed these two commands together. We've composed the git commit fix up command with the GPS SHA command. And now this composed command is now operating conceptually at the level of patch stack, not at the level of Git. This is awesome. But what if you use this all the time? It's a pain in the ass to have to do this and type this out every time and do the compositions every time. Well, okay. It's not a big deal. You just make an alias. You can go make an alias in Git that does this and has an argument placeholder in place of that number 4 for the index. And you're good. Or if you want even more power, you can make the alias in your shell configuration. And guess what? You have it. So now anytime somebody opens a proxy command request, I just tell them, go make an alias, use this for composition, and give them an example. And it's just copy and paste. And I think that that's the new direction that we're taking in terms of this flexibility of creating your own personal development experience, because that's really what's going on here is all of these different developers all have their own slightly different personal development experience, their own way that they have their machine configured that works for them. And this is just trying to facilitate and provide those core concepts so that they can create the personal development experience that fits their needs. So on to shift number 3. Shift number 3 is platform agnostic. So Git Patch Stack is written in Rust. Rust is a extremely cross-platform language. Because of that, we already supported Mac OS and Linux before. But we didn't really support Windows. And so we decided as part of this, because there were a few people that were like, hey, it'd be great if, you know, I could use this on Windows. And I was like, who the hell uses Windows? And they're like, we do. I was like, all right, I guess there's no reason that it shouldn't work on Windows. So like, let's look at the things that aren't working on Windows and see if we can fix those as part of this. And it wasn't too hard. So there were a few libraries that weren't cross-platform that we were using that only worked in Unixy environments. And so we swapped those out for ones that were cross-platform and worked across the board. One of the bigger things was that we, before 7.0, we supported GPG signing of your commits. So if you're a user that uses Git and GPG signing, we supported that before. But we supported that by integrating with the GPG C library, and getting that C library to build on Windows was a no-go, right? So we decided to look at what Git was doing, and Git escapes this whole thing by not integrating directly with the library to do it. Instead, they shell out to the GPG program that's on that machine, if there is one. And so they don't have to worry about that. So we decided to do exactly the same thing. And instead of linking to the library directly, we just got rid of that dependency. And now we shell out and we actually read the configuration directly from the Git configuration. So the same way Git does it, we use exactly the same configuration to do GPG signing the same way. And that alleviated that, allowing us to now build and run on Windows machines. So while we were working on signing, we also had some requests for SSH signing support, which is kind of a newer, more popular way of signing your commits that's been introduced in Git. And so we were like, sure, why not? Let's add SSH signing support in while we're at it. And we did that too. That's all of our major shifts that we've made. Okay, but that's not everything. We, of course, decided we got to improve our lives. Beyond these major shifts, we need to make things better. So we added this integrate verify hook, which is a hook that gets executed as part of the integrate process. And the intention with this hook is that if you remember back to the beginning when we were talking about state and sources of truth for state, there's really two sources of truth for state that we primarily care about in Patch Stack. One is Git. The other is whatever the source control hosting provider is that we're using for doing peer reviews, right? So that could be GitHub for most of us. In most of the cases, could be Bitbucket, GitLab, whatever. Doesn't matter. It works with any of them because of this hook infrastructure that we provide. But the idea with this is that as part of the integration process, you shouldn't be able to integrate unless your pull request has met all the necessary checks, right? So on GitHub, you want to make sure whatever your checks are that are configured, whether it's that multiple people have reviewed it, whether it's that the thing passed your CI test, passed whatever your various builds are, this sets it up so that as part of your integrate, it can go ask whatever the source of truth is for that state, if it has passed all of those checks, and then abort or allow you to continue the integration process depending on that. So that's the integrate verify hook. What other quality of life stuff? Oh yeah, this is actually one of my favorites. I think this is probably my favorite. This is more of my favorite, I think, than patch series support. So what does this mean in rebase support? Well, I think the best way is to look at an example. So let's look at an example. We got this patch series here. Got this patch stack. It's not turned into a patch series. These are all independent solo patches in our patch stack. And let's say we want to, edit the add login client patch in the middle. It's somewhere in the middle of this thing, index number 3. All right. So we do a GPS rebase. We flag that patch for editing. And then we get this. Dumps out and it says GPS rebase stopped at E748727 add login client. So we know we're in the middle of a rebase because we just kicked it off and we told it to stop in the middle of a rebase so we could edit a patch in the middle. And we know that it stopped at the one we requested it to stop at. But it doesn't give us a lot of context as to what's actually going on or how our stack relates to where we are. And if I'm in the process of like editing, I could be editing a bunch of different ways. I could be adding commits in, like trying to stack more stuff on my stack in the middle. And like, what does that look like? And sometimes I get distracted with chat and I need to come back and get context. And so this isn't super helpful for all of that. So, but now with 7.0, if we just run GPSLS while we're in the middle of a rebase, it now shows us this. And so if we look at this, first of all, it tells us in big red letters at the top, hey, rebase of main is in progress and we're rebasing onto this commit. But then we'll notice that it also has the actual current state of the patch stack in the middle of the rebase down at the bottom. So we see patches 0 through 3, right? And we can see all of those patches. And we can see that right now, add login client is the most recent commit on top of our stack when we're in this current state in the middle. But then we can see these other things above. And this other thing above, I'm not sure if you all are familiar, but when you do a Git rebase, behind the scenes, what Git is doing internally is it's keeping track of basically a to-do list. When it basically analyzes your tree to figure out what commits need to be replayed, and then it puts all of those into a to-do list, which is just a file that's stored inside of Git, but it's a track of like all the things it needs to do. And they have different commands, and you're akin to seeing this when you do the Git rebase on the command line tool as an interactive rebase, because you get to pick those different commands. Like we picked edit for the beginning of this example, but pick is the default one, which just says, hey, replay this commit, right? Turns out that you can get access to and see that to-do file as you are making progress going through the rebase. And that allows us to actually get the to-dos, which are the remainder of our stack that has not been replayed yet. And so if you kind of squint and squash these two things together, you'll realize that the commits on the top and the stack at the bottom are really, if you squash them together, are the representation of the stack. But this is showing us which ones have not been applied yet, and in the appropriate order, so you can keep track of and always know what state you're in. So that's in rebase support. All right, that's not it. We also added ahead and behind counts. So if you look at this top line where you run GPLS, normally you'll see it says main, which is the branch that's our patch stack. And patch stacks in Git Patch Stack are just branches that have upstream tracking branches. So you can have as many patch stacks as you want, but GPSLS tells you which one you're on, and it tells you which branch that branch is tracking for a remote tracking branch. In this case, it's origin main. That's useful and meaningful because now we have a head and behind, which tell us useful information about those things. So a head tells us how many patches we have on top of the origin main or the base of our patch stack. And then behind tells us how many patches our patch stack is behind in terms of its base. So the scenario, like you want that to be 0 when you're up to date. But in the scenario where, let's say I'm working on some patches locally and Claude goes and integrates like 3 other patches into main, okay? And I do a fetch so that my local Git knows about the remote stuff, but I haven't actually updated. I haven't done a pull to do a rebase. I've just fetched. If I then do a GPLS, what I would see is that I'd be behind 3 patches, right? So it'll tell me that, hey, some other people have integrated some stuff since your patch stack was last rebased. Maybe you should run a GPS pull to rebase and update on top of it. So it's a mechanism of helping keeping you informed that and letting you know that you should probably update. So that is ahead and behind. Okay. There is a crap load of other quality of life improvements. I only picked a handful of stuff. If you go look at the changelog for details, you will see them all. It is very long. There's a lot of stuff that we did as part of 7.0. So I hope you enjoy. I have nothing else for you other than answering any questions you may have. And I'll be happy to show you anything too if you want to see something that you didn't think I went into detail enough on. But that's it. That's Patch Stack 7.0.
I have a question.
Yeah.
So I don't know a lot about graphite, but I've heard a lot of other people mention it in like the GPS channel. So I guess what's the difference between graphite and GPS? And like,
Sure.
Are the changes of 7.0 sort of closer to what graphite does?
Yes and no. So let me try to explain. So graphite is a graphite.dev is the website, and there's a company that produces a tool, but it is what we call a stacked branch workflow, not a patch stack workflow. So that's the core difference. Is there's kind of 2 categories of workflows going on in the Git world right now, that are like new agey workflows. One is patch stack, which is what Git Patch Stack is focused on. One is stacked branch. So the fundamental like idea with stacked branch workflows is like, if you back in the day, if you pretend you have no other tooling and you just have Git, okay, let's say I build feature A, I created a branch for it using a feature branch. I build feature A, I open a pull request for that. It takes people days to review my big feature branch, feature A. We'll call it feature A pull request, okay? Meanwhile, I need to go continue doing work. If that work depends on feature A, then what I have to do is create a new branch based on feature A's branch, and I go do my work on top of that in feature B branch, which is dependent on feature A branch. So I've stacked a branch on top of another branch, okay? I can go do that work. Meanwhile, somebody reviews feature A and comes and tells me, hey, you need to change this and that and this and that, okay? So I go back to feature A branch, make those changes. But now that I made those changes, I've broken the dependency chain of feature B to feature A. So I need to go rebase feature B onto the new feature A to get it up to date and then apply those changes. That's how we do manual stacked branch workflow. Graphite.dev is a tool to facilitate doing that workflow where you are doing that process, but automating the rebasing on top of each other portion of it. Okay. And so to facilitate that, what you do is you have to define the relationships between these things up front, right? So you have to declare, hey, I'm creating this branch and give it a name, whatever, and that's your branch. And then you declare, hey, I have this other branch, but it's related and dependent to this branch because we want feature B to be related and dependent. So you have this additional tooling that lets you define this directed acyclic graph of relationships between these branches. And then because the tool knows those relationships to those branches, it can automate that stacked rebasing for you, right? And so in addition, so graphite.dev, they push the same thing that we push with Patch Stack, which is this idea of these smaller, more atomic commits, right? And they push the same thing, but they're pushing that with this stacked branch workflow where basically for every commit, you create this small branch that you have to then define the relationship of between these other branches and then let it do the automatic rebasing. Now, the interesting thing about it is that when you do a request review of those things, you can do like, you can say, hey, I want to open pull requests for this branch, or you can say, I want to open pull requests for these 3 branches. And with graphite.dev, it opens 3 separate pull requests, one for each patch in a stacked pull request manner, which is weird and broken in GitHub proper. Like GitHub's not designed to do that. And so what they do is they sell an extension to the GitHub experience, a web interface that understands the directed acyclic graph that the tool knows about, so they can understand the relationship between those pull requests, and they push you to and your team to go do all of the peer reviews in this other tool. That's an extension of GitHub. So now looking at like Patch Stack, the difference is that we, instead in a Patch Stack workflow, you're not defining relationships explicitly between branches and doing it up front. You don't think about branches at all. You just think about the patches, and your relationship is just a matter of ordering those patches in your linear history, right? Or in your linear stack, which eventually will become your linear history. So that's the difference. Now, Patch Stack has the same information. Behind the scenes, we have or could generate a directed acyclic graph of the relationships of our patches because we have the ordering, which tells us the relationship of those patches, right? It's not as explicit as if you manually declare that, but we have that ordering information there. And so we could assume that there are dependencies in that order, and therefore you need to have those pull requests get stacked in that order. There have been numerous requests from people asking us to add that support so that when you run some command, it opens separate pull requests for each of these things in a stacked manner. I've pushed against doing that every time because it's super brittle and broken inside of Git, inside of Bitbucket, inside of GitLab. None of them support that model of doing peer reviews. And so it's like a bastardization and a like a really brittle way to do reviews that, if people aren't paying attention when they're doing reviews, can mess things up big time. And so I've kind of pushed back and told people, no, we don't really do that because of this. And like the reason is like we don't have a product that we're selling that's a completely separate web interface and experience to manage that thing. And the niche that we're like trying to hit is that we want to be a tool that supports working in cases where it could be the whole team, but maybe it's just you, Frankie Lee, who likes working locally in the patch stack workflow, and you want to be able to do that workflow, but you're working with other developers from a client, say that, you know, they do feature branch development, right? Like, so you don't want to be in a situation where you force the whole team to have to adopt some new tooling and new system of doing peer reviews. Instead, we take the stance of, cool, well, we want to facilitate you being able to do this workflow, but in a way that fits in with the existing paradigms that people are used to for doing peer review. So hopefully that answers the question.
Yes, thank you.
Yeah. Cool. No other questions? Nothing? All right.
All right.
Nobody wants to see anything?
I'm gonna use it, so I'll
Yeah, I'm
see
just
it.
gonna use it.
All right. Yeah, it's updated in Homebrew. So if you do your brew update, brew upgrade, git dash ps, whatever, you should have gotten a notification if you just run whatever command it is that tells you there's a new version. I forget.
Do you
But,
actually, oh, sorry.
Yeah, go ahead.
Do you have a like some of the samples of like some of the aliases, I guess, that would be most common that you could post in Slack or something?
We don't have a bunch. I mean, if you want, if you ever get stuck with, I have a couple that people used from issues that they opened and they're like, how do I do this? And I responded with like, here, you could do this with GPS SHA now. So I have a couple examples, but we don't have a ton. I don't use a lot of them because I guess I don't know, maybe that's a side effect of the fact that I built GPS kind of for me initially and around the workflow that I do. But yeah, I have a bunch of aliases that I use, but most of them are not they're not aliases that integrate GPS into things. They're just aliases that I use to make my life easier for my personal development experience. Like I know Harris has a bunch too. Like if I'm watching Harris do something, I'm like, I have no idea what his aliases are he's using and what they're doing. And that's fine. That's like I have a bunch of those too. So but yeah, all of my aliases, I share my git config. So all my git config aliases are available as examples for defining aliases. All my Zeesh configs are shared as well. So any aliases in there could be, but like, yeah, if you're ever trying to do something, like you can always hit me up and maybe we'll start like a little examples file of different aliases. That might be a good idea.
Yeah, I was gonna suggest maybe on the documentation page or just on the README, it's just here's the collection, here's the link to the issue that brought it up.
Yeah.
Like, because yeah, maybe there's a workflow that you're like, I could discover and be like, oh yeah, it'd be great to have that alias that will solve something I've been doing that's a little more tedious.
Yeah, here, let me
Basically, the way I think of it is anytime you have to do a get log to get a SHA, don't. Just you would get that get SHA or GPS SHA command and use the patch index instead.
Yeah, so there's other cases that for other commands too. The more that I thought about this, like a guy hit me up a couple days ago and was like, hey, how do I do a GPS rebase -- auto squash? And I was like, oh, you're right. We don't proxy the auto squash option. And rebase is one of those things that is the closest thing, the only command we have left that's close to being a proxy command. And so, but it's like core enough to the workflow where I don't really want to remove it as a command and force people to define an alias to get it. But then I started thinking about it, because that's basically what this guy would need, would be a GPS rebase that is different, because he wants a GPS rebase that does an auto squash as part of it. And so I started thinking about, like, well, the actual Git rebase that's happening has a few different values in it. It's not just SHAs. It's not just mapping from a patch index to a SHA. It's like passing in information about what the remote is and what the branch name is and things like that. So it's like, it got me thinking, like, from a purely compositional standpoint, it would be great if those things were also exposed as commands, because then it would allow people to define their own GPS rebase command, for example, to do what they want. And so ended up, like, after talking to that guy a bit, that he ended up just setting it in his config, because you can enable auto squash in your Git config as well for rebase. So that's what he ended up doing, and it works fine. But in terms of composition in general, I think there's still room for improvement in terms of composition and exposing other commands. One, can you still see my screen?
Yes.
So I updated the website as well. So the website has all of the stuff, and you can see that all the documentation has been updated for 7.0. So if you want to go see documentations on the new hooks or how to configure colors and all of that stuff, it's in the documentation. All of the guides for how we do things have been updated for 7.0, so you can reference all of the guides for how you add patches, how you split patches up into multiple patches, how you absorb changes from a remote branch, how you request review, how you combine patches, et cetera, et cetera, et cetera, et cetera. So yeah, all of this has been updated. I also, if you go to the engineering site for Uptech and you go to the blog, there's a blog post that talks about all the stuff I talked about in the presentation in more detail about the 7.0 release here with all of that stuff. And yeah,
Great.
join the Slack group and ask questions later on. Happy to answer any questions there too.